Over a mere 72 hours, a pair of stellar explosions burst forth with enough intensity to become visible without aid. Twin magnitude 6 tremors ripped across Venezuela, while a huge solar flare collided with the sole verified interstellar comet gracing our solar system. Researchers dubbed this intense period the 72-hour stack. Yet nobody anticipated the simultaneous onslaught, encompassing even Earth itself, enduring a straight-on blow from a coronal mass ejection. The chances of this blend of celestial and tectonic upheavals are slimmer than 1 in 1,000. Could this be mere coincidence or evidence of an overlooked underlying trend? A cluster of uncommon high-impact occurrences squeezed into just 3 days. Curious about the improbability? Let's dissect it. Typically, our planet witnesses perhaps a single naked-eye nova annually, and occasionally zero. Here, 2 ignited brilliantly enough for casual skywatchers to spot them sans binoculars, erupting within a span of just 36 hours. In Venezuela's vulnerable zone, a magnitude 6 shaker hits roughly once every 2 to 3 years. But 2 significant jolts, accompanied by a potent aftershock, hammered the identical area in under 6 hours. At the same time, our sun, already agitated at its cycle's zenith, flung a coronal mass ejection directly into the trajectory of that interstellar visitor, a sighting so exceptional it's merely the 3rd authenticated ever. Crunching the figures, the likelihood of every incident converging in one 72-hour span plunges beneath 1 in 1,000, perhaps far lower based on the calculations. Experts term this Poisson clustering. Occasionally, chance deals out a combination so extraordinary it seems rigged. The probability of spotting 2 naked-eye novae over 3 days? Under 0.002%. Back-to-back Venezuelan quakes of that scale? Around 1 in 10,000. Factor in a coronal mass ejection grazing 3I/Atlas precisely as it approaches the inner solar system, and the odds become so astronomical that computations falter. That's precisely why veteran experts are labeling it an event stack. Beyond the scarcity of each component, it's their precise alignment that renders the entire episode feel downright implausible. The term is already buzzing in astronomical and geophysical communities as a shortcut for that bizarre stretch when cosmic norms appeared suspended. The data speaks volumes. This qualifies as a supreme statistical anomaly, which explains its irresistible pull, urging detailed scrutiny hour by hour to grasp how these improbable happenings intertwine so snugly. The sequence kicks off shortly past midnight in Universal Time. At 2:12 a.m. Universal Time coordinated on September 23rd, Nova V 1935 Centauri suddenly blazes into view. Observatories in Chile and South Africa snag the flare almost immediately, with robotic notifications recorded and official verification arriving within the hour. In Centaurus, nighttime lingers profoundly, yet the update ripples across global channels by European morning. Jump ahead to the evening of September 24th, pinpointed at 22:21 Universal Time coordinated. Seismic instruments throughout the Caribbean detect a abrupt, shallow fault break, a magnitude 6.2 quake close to Mina Grande, Venezuela. Its focus lies roughly 7.8 kilometers down. On local dials, it's 6:21 p.m., right amid supper time for locals. Preliminary updates flood the Venezuelan seismic agency's streams mere moments later, mirrored swiftly by the USGS and EMSC in their worldwide logs. Under 6 hours on, at 3:51 Universal Time coordinated September 25th, the Earth rumbles once more. Now it's a magnitude 6.3 event, dipping to 14 kilometers depth. The surrounding territory stirs violently anew. Trailing tremors, one nearing magnitude 5.8, pulse outward over the next 60 minutes. Hospital records and instant messaging threads capture the turmoil live as healthcare teams rush into action. Only 14 minutes post-second quake, at 4:05 Universal Time coordinated, a fresh stellar warning pings. V7994 Sagittarii surges to prominence, cresting at magnitude 6.2. Detection systems broadcast the fine to open channels, while broad-spectrum detectors capture gamma-ray and X-ray traces. Hobby stargazers start swapping insights with specialists. Quietly in the mix, the sun approaches a pivotal surge. Throughout September 25th, a coronal mass ejection, dispatched the day prior, barrels across the Sun's inner domain. Projections align its reach with 3I/Atlas's anticipated route inside an 8-hour slot. Timings focus on roughly midday UTC, though exact sync hinges on updated orbital data and solar wind speeds. The Space Weather Prediction Center dispatches warnings seconds after each fresh metric, as astronomers and comet enthusiasts monitor the charged cloud's advance. Though every marker ties to universal time, each incident imprints distinctly on the ground. Chile's scopes braving pre-dawn cold, Venezuela's clinics amid dusk power cuts, solar observers glued to live feeds. Layer by layer, these occurrences, etched minute by minute, craft a chronicle as packed as anything in modern recollection. Every pinpoint represents a stake on the chart of an astonishing 3-day span. A nova isn't merely a fleeting glow-up. It's a violent outburst on a white dwarf, a stellar corpse that stealthily siphons hydrogen from its orbiting partner until those vital elements trigger uncontrolled nuclear fusion. Within hours, the star's brilliance can explode by a factor of 100,000, surpassing the combined light of a billion suns. That's precisely what unfolded right before daybreak on September 23rd, as V1935 Centauri, a dim speck in Centaurus, flared to magnitude 5.8. Visible to the unaided eye from a clear, dark site, this was an uncommon sight even for veteran stargazers. Gabriela Moya, a hobbyist astronomer based in Valparaiso, Chile, became the initial verifier of the flare-up. She dedicated the evening to operating distant telescopes, hunting for anomalies. Undeterred by overcast skies and electricity failures, she pushed on, fueled by excitement and the weight of pioneering the find. Whispers of the nova buzzed across Discord groups, yet Moya held out for solid proof. By the time her update hit the Central Bureau for Astronomical Telegrams at 0212 UTC, she hadn't rested in over 48 hours. Her notification sparked a cascade of robotic verifications throughout the southern skies, and shortly after, the nova's position lit up international data streams. The allure of a nova stems from its underlying mechanics. Hydrogen accumulated from the binary companion accumulates on the white dwarf's exterior, squeezed by gravitational forces until heat exceeds 10 million degrees. The fusion process spirals out of control, hurling surface material into the void at speeds of thousands of km/s. This detonation generates a blast front that tears through the expelled material, superheating it to radiate in optical wavelengths, plus stronger signals in gamma rays and X-rays. For V1935 Centauri, space-based observers detected distinct gamma-ray and intense X-ray traces right as the visible peak hit. These mark the hallmarks of intense collisions, proof that the surge was propelling particles close to light speed and likely crafting dust particles in its wake. Barely 48 hours afterward, yet another white dwarf in Sagittarius, dubbed V7994 Sagittarii, mirrored the drama, climbing to magnitude 6.2, barely perceivable without aid. The find ignited arguments as various observation squads vied for credit on the earliest spot, with updates ping-ponging from observatory records to online forums. Orbiting instruments like Fermi and Swift seized the action nearly immediately, logging a sharp rise in gamma and hard X-ray fluxes. In-house discussions at NASA and within the Fermi group postponed the official reveal while scrutinizing for glitches. Once confirmed, a flood of draft papers emerged, each dissecting the collision dynamics and particle boosts fueling the blast. Connecting these novae is the ferocity of their collision signals, evident in both luminosity profiles and energetic outputs. These aren't subtle illuminations, but explosive nuclear detonations in distant binary pairs, light years off, still vivid enough to inscribe their tale onto our night sky. The initial tremor hit shortly after dusk, close to Menantial's Grande, clocking in at magnitude 6.2 and just 7.8 kilometers deep. That proximity to the surface let the break propagate directly upward, rattling residences and whipping utility poles. The nearby medical facility, already low on resources, hastily organized outdoor sorting areas amid the ongoing jolts. Veteran nurse Maricela Rivas, fresh off duty, plunged back into the chaos, directing folks to marked sheets laid out in the lot. Her calm instructions via the facility's WhatsApp chat detailed wounds and pressing requirements as helpers assembled temporary hydration points and shifted the gravest patients clear of damaged structures. 5 hours on, the Earth shuddered once more. Now a magnitude 6.3, seated 14 kilometers below, but aligned right under the prior zone. The progression mirrored standard strain migration, one fracture plane yielding, then stressing the adjacent one. Experts from the University of Los Angeles, laboring overnight, traced the tear's advance through the Okanagan fault system. Their breakdown highlighted a standard decline in aftershocks, following a Mori's principle. The strongest jolts first, trailed by diminishing quivers. In under 60 minutes, a magnitude 5.8 replica shook things up anew, compelling another exodus from the premises for patients and crew. Kitchen staff doubled as sentinels, eyeing structures for new fissures and signaling clearance to re-enter. The early chaos revolved around quick fixes. Limited to 3 surgical setups and spotty electricity, Rivas's crew focused on kids and dire injuries. They shuttled cases outside during rumbles, relying on torches to insert drips and track signs. Community broadcasters aired dispatches from the site, airing pleas for gear and clear paths for emergency vehicles. During that stretch, the center evolved into a hub, not only for healing, but for intel sharing and group organizing. Analysts poring over the Tremor series stressed that even with the sequence of tremors adhered closely to familiar seismic behaviors. In this region of Venezuela, the Earth's crust endures ongoing pressure from the gradual clash between the Caribbean and South American tectonic plates. As one section shifts, the built-up tension shifts elsewhere, occasionally sparking a fresh break in the vicinity. Every subsequent shake served as a stark alert that, amid a period when cosmic chances felt upended, the ground underfoot remained governed by its timeless principles. This year's solar peak goes beyond mere jargon. It's an everyday occurrence. Sunspot counts have climbed to 165, with solar radio flux steady above 180. Such conditions foster frequent coronal mass ejections, as the sun regularly hurls out thick bursts of plasma every couple of days. Yet the real twist lies in what's now coexisting with those solar outbursts in the inner solar system. 3I/Atlas. As the third verified interstellar visitor, 3I/Atlas defies conventional paths. Its trajectory runs sharply backward, barely grazing the ecliptic plane, and it hurtles along at more than 60 kilometers per second, far quicker than ordinary comets. This course pulls it to within 0.19 astronomical units of Mars on October 3rd, prompting Mars mission crews to prepare for potential photo and spectral data captures during the near pass. Unlike the comets we typically examine, which originate from the Oort cloud or Kuiper belt, 3I/Atlas hails from a distant stellar neighborhood, transporting substances and gases older than our own sun. Its arrival feels perfectly timed. Traversing the solar system at the height of solar cycle 25, it encounters the most dynamic and potent solar wind we've observed in over 10 years. This setup positions it as an ideal test for plasma dynamics, with its surrounding gas envelope and trail offering live insights into how alien matter reacts under extreme solar conditions. Dr. Stephen Burns, a geophysicist renowned for studies in solar terrestrial dynamics, describes this transit as a rare, era-defining study. He emphasizes that although we've witnessed CME effects on local comets in the past, this marks our first opportunity to observe such an event on an extraterrestrial interloper. The proximity to Mars introduces extra intrigue, as experts rush to align data from spacecraft like TGO and MAVEN. Each piece of information collected could unlock clues about the comet's history and the mechanics of plasma behavior during solar maximum. Thus, as 3I/Atlas glides by Mars en route to perihelion on October 29th, it transcends mere novelty. It's a prime focus for heliophysics and planetary research. The sun's ramped-up output, combined with the comet's atypical route and this encounter's alignment, transforms standard solar turbulence into a fleeting chance for breakthrough science. October promises to etch itself into history, with multiple chances for stargazers and citizen scientists to participate hands-on. The upcoming spotlight falls on October 20th and 21st, when Comet Swan, cataloged as C/2025 R2, swings nearest to Earth at just 0.26 astronomical units, roughly 39 million kilometers. Coinciding with the new moon and the Orionids meteor showers climax, the setup is ideal for spotting the comet's dim trail. For optimal sighting, venture out post-midnight, away from urban glow, and let your vision acclimate for at least 30 minutes. Optics like 7x50 or 10x50 binoculars will enhance the view, and a constellation map or mobile app can direct you to Swan's spot as it drifts across the early morning heavens. Come October 29th, 3I/Atlas hits perihelion, its sun closest mark at about 1.36 astronomical units. Though invisible against daytime skies, seasoned viewers might attempt crepuscular or pre-dawn glimpses, but with utmost care. Avoid staring toward the sun without ISO 12312-2 approved solar filters, and refrain from binoculars or scopes without a filter fitted firmly over the objective lens. A momentary unprotected peak risks irreversible vision harm. In pursuits like comet tracking or nova spotting, endurance is essential. Building dark vision matters most, so opt for red lights or low-brightness displays to safeguard it. The final key moment arrives on December 19th, with 3I/Atlas at its Earth-nearest point, around 1.8 astronomical units distant. Here, the comet offers the easiest access for hobbyist photos and naked-eye checks, particularly if its output intensifies post-perihelion. Groups such as the AVSO, International Comet Quarterly, and Comet Observation Database are urging submissions of brightness readings, tail drawings, and sequential images. Spot anything odd, like a flare-up, tail twist, or apparent fragment. Record the timestamp, site, and gear used, then cross-check with fellow observers prior to submitting to verified outlets. Thoughtful submissions distinguish real finds from clutter, ensuring the info aids professionals effectively. If leading communal stargazing sessions, particularly involving children, go over essential precautions as twilight fades. Prohibit any unprotected sun gazes. Ensure all viewing gear stays. Make sure telescopes are aimed far from the sun, and share updates on approved filters along with proper laser handling. The thrill of these occasions often leads to risky decisions, yet a brief pause for safety safeguards vision and research integrity alike. With October and December on the horizon, the heavens extend an uncommon opportunity, one worth embracing through sharp vision, precise techniques, and a balanced offer marvels and precautions. Within a mere 72 hours from September 23rd to 25th, 2025, two visible to the naked eye novae, paired magnitude 6 tremors in Venezuela, and a solar plasma burst crossing paths with 3I/Los all took place. The recorded odds of such a sequence are under 0.1%, as fresh insights emerge from key events like the Mars Close Pass, Swan's nearing, and closest solar approach. Collective sightings and thorough reviews will distinguish random chance from true links. The evidence remains. At times, the cosmos's most unusual alignments unfold right before our eyes.